For this problem, you'll need a graphing calculator. The preferred calculator of choice is either the TI-86 or the TI-84. And as you can see here, we're going to be graphing a rational function and this function f of x. So just some words of advice is make sure that when you're entering this function into your graphing calculator to be graphed, that you include the parentheses around the 5x, and then you hit the division sign, and then you put parentheses around the x squared plus 1, so that way it graphs this function appropriately. So here we're asked to sketch this graph by just plotting and labeling a few points, 8 to be exact, and we'll show that this graph is asymptotic. So I'll draw let me get a table over here and keep track of the points that we're graphing. And let's see, I will start with, I'll start down here in the middle because I'm gonna plug some points from the negative and the positive side, some negative and positive values, but I always like to start with 0 to see what's happening here. So if I plug in 0 for my x here, the output that I get is also going to be 0. Okay? So that's one of my points that I can plot on my graph. And then I'll work my way out from 0. So I'll plug in a 1, and let's see the value that I get, and I'm just plugging these values into my calculator. I have the function set up, and you get a 2.5. So if I go over here to 1, go up to halfway in between 2 and 3, 2.5, and then I'll plug in negative 1, and I get, let's see, negative 2.5. Down here. Then, let's see, I'll plug in, what's the value? Let's plug in negative 2, and I get a negative 2. Go here, and I take a positive 2, and I get positive 2. So you can kind of see the pattern that's forming here. So I pick one more negative value, say negative 3, and this will give me an output of negative 1.5. 3, so it's here, and let's see, I'll plug in 3 here, and I get you guessed it, 1.5, positive 1.5. So, and then one more here on the positive side. So if I plug in a 5, now I'm starting to get these decimals, so 9.96. So now, and if I sketch this out, on the positive side I end up with something that looks like this, and as I continue to plug in values, what will happen is this gets closer and closer to the x-axis, but it's not going to touch it. And then same thing will happen if I go in the negative infinity direction. Here, something like this, and it continues on, but never crossing the x-axis. Okay, now that we have the graph sketched, and we want to go ahead and label the points where the extrema occur. In other words, the relative max and min. In order to do this, you're going to need to utilize the max and min feature on your calculator to be able to get the exact values. Now I'll start with um, the relative max. It looks like it occurs somewhere. This is around the area for the relative max. And when I use my calculator, the max min or the maximum feature on my calculator, it gives me the value of 2.5 as my maximum. It occurs whenever I plug, and you can see whenever I plug in a 1, I get positive 2.5. All right, and I can actually put that value here. And I do the same thing over here by observation. I observe that somewhere over here, this looks to be the lowest point in this area. So that looks like my relative min. And again, using the min feature, the minimum feature on my calculator, I get negative 2.5, and that occurs when I plug in negative 1. All right, and that also answers this question here.